Reverse swing of cricket ball. We have to explain reverse swing of cricket ball. This is the direction of initial flight of the ball. This is the direction of initial flight of the ball. Now we can draw the seam, and this is the seam of a cricket ball which is angled at certain angle towards offside of a right-handed batsman. This is the seam of a cricket ball angled at 20 degree towards towards the offside of a right-handed batsman. Air is flowing in the opposite direction. Air is flowing in the opposite direction. This is the direction along which air is flowing. So these are the different layers of air which are flowing in the opposite direction of flight of the ball. Flight of the ball. And here air flows on the seam side in this way. Air flows on the seam side in this way. And this air flow on the seam side will be turbulent. This air flow on the seam side will be turbulent. This airflow is converted into turbulent state relatively early before reaching the seam location. Here we can denote different eddies in this turbulent flow, and we can denote the point of separation of this turbulent boundary layer of air. A is the point of separation of this turbulent boundary layer from which it is separated from the non-seam side of the cricket ball. These are the eddies. That means this boundary layer is in turbulent state. The boundary layer touching the seam side of the cricket ball is in turbulent state. And in this case, the seam of the cricket ball has a detrimental effect on turbulent boundary layer by making it thicker and weaker. Rough side is on the non-seam side of cricket ball, and smooth side or extra rough side is on the seam side of the cricket ball. So this boundary layer is in turbulent state, and we can denote the direction of airflow, and this airflow is in turbulent state. This airflow is in turbulent state. That means airflow maintains turbulent state on the seam side of the cricket ball, and we can denote another layer of air touching the rough side or non-seam side of the cricket ball. We can denote the point B, which is the point of separation of boundary layer from the rough side or from the non-seam side of the cricket ball. So this is the boundary layer. This is the boundary layer which will also be in turbulent state, touching the non-seam side of the cricket ball or touching the rough side of the cricket ball. And this boundary layer is also in turbulent state. These are the eddies in this turbulent state, but this turbulent boundary layer will be separated from the point B. So that means turbulent flow will occur on both the sides of the cricket ball. But the turbulent flow is separated lately from the point B on the non-seam side of the cricket ball, and lower pressure will be acting on the rough side or non-seam side. And as the turbulent flow is weak on the seam side here, so higher pressure will be acting on the seam side or on the smooth surface of the cricket ball, and the ball will swing towards leg side. The ball will swing like inwards, like in swing, but the seam was placed same as the conventional outswing. So that means ball swings towards the leg side of right-handed batsman, and this is called reverse swing. In reverse swing, the seam of the cricket ball will be pointing towards offside, same as the conventional outswing, but it will swing like a conventional in swing. That means the ball swing in the opposite end of the seam side. Reverse swing occurs here. The reverse swing occurs towards the leg side. That means reverse swing occurs in the opposite end of the seam side of the cricket ball. Seam is pointing towards offside, but the ball will swing in mid-air towards leg side before striking the ground. In the mid of 1980s, few cricket bowlers, especially Pakistani bowlers like Imran Khan, Wasim Akram. In the mid of 1980s, few cricket bowlers, especially Pakistani bowlers like Imran Khan, started to produce a newer version of swing bowling. Especially with the old ball after 40 overs. They produce a newer version of swing bowling, especially with old ball after 40 overs. It is termed as reverse swing. It is termed as reverse swing at it swings in the reverse direction of. It was termed as reverse swing as it swings in the reverse direction of conventional swing, having the same seam direction or seam position. It turned out that at high speeds, the ball started to swing in mid-air against the direction of seam position of the cricket ball. Again, we can draw the diagram of a cricket ball which is thrown in mid-air, which is thrown in air. We can draw the wickets at the batsman end. These are the wickets at the batsman end. Wickets of batsman end. The seam is angled towards offside with respect to right-handed batsman. This is the seam position which is pointing towards first slip fielder of the right-handed batsman. Seam is angled towards offside at certain angle. This is offside of a right-handed batsman and leg side of the batsman. And the ball will swing towards leg side, though the seam was pointing towards offside, and that is called reverse swing. This is what seam direction, and the ball will swing towards leg side in mid-air. Though the seam was pointing towards offside, but the ball swings. In the reverse way, the ball swings towards leg side, or the ball swings in the reverse way in the opposite end of the seam position. Rough side is placed towards leg side, and shiny side is kept on the seam side. And delivery of the ball will be delivery of the ball and seam position is same as the conventional outswing. In this case, the ball will be thrown or delivered with the same seam position as that of the conventional outswing, but the ball will swing as in conventional inswing. But reverse swing occurs with the old ball. That means generally the reverse swing occurs with the old ball after 40 overs. The ball should be thrown at certain speed. That means the ball should be thrown at minimum 85 miles per hour. Now we can compare conventional outswing and a reverse swing. Comparison between conventional outswing and a reverse swing. For conventional outswing on the left hand side, for conventional outswing, the seam is pointing towards first slip fielder of a right-handed batsman. That means seam is angled towards offside of a right-handed batsman in this way, and we can draw the wickets at the batsman end. This is the offside and leg side. The seam is pointing towards offside. On the right hand side for reverse swing, seam is angled towards offside, same as the conventional outswing, and the same side for conventional outswing. For conventional outswing, the seam side of the cricket ball should be rough, and for reverse swing, the non-seam side of the cricket ball should be rough in nature. In this case, turbulent flow will be on the seam side of cricket ball. Turbulent flow will be boundary layer will be in turbulent state on the seam side of the cricket ball again, but turbulent flow will be on the both sides for reverse swing. For reverse swing, turbulent flow occurs on the both sides of the cricket ball. That means turbulent flow occurs on the seam side and also on the non-seam side of cricket ball. For conventional outswing, ball swings outwards in the same direction of the seam position. Ball swings in the direction in which the seam is pointing. The ball swings outwards in the same direction of the seam, but for reverse swing, the ball swings in the opposite end of the seam position. The seam is pointing towards offside, the ball swings inwards for reverse swing. When a cricket ball which becomes old, when a cricket ball which becomes old enough after 40 overs is thrown in air by a bowler, towards a right-handed batsman, at minimum speed. When a cricket ball is thrown by a bowler in air towards a right-handed batsman at minimum speed of 80 miles per hour, that is with a speed of 140 kilometer per hour, with the seam angled 20 degree towards offside, that means 20 degree towards the first slip fielder of a right-handed batsman, with a backward spin at 11 revolutions per second, such that its rough side is pointing towards leg side, or on the non-seam side, and the air will be diverted. Then the air flow will be diverted in two different directions, one toward non-seam side and another toward the seam side of the cricket ball, which disturbs the flow of air and makes the flow turbulent. The turbulence at the rough side, that means the turbulence on the non-seam side of the cricket ball, is more than that of the seam side of the ball. Here, seam of the cricket ball is angled towards offside of a right-handed batsman. Air is flowing in the reverse direction, and non-seam side of the cricket ball is rough in nature, and seam side is smooth. This is the seam side which is smooth or extra rough, and this is the direction along which the cricket ball will be thrown. This is the direction of initial flight of the ball. Air is flowing in the opposite direction. This is the direction of airflow. Air is flowing in this way on the two sides of the cricket ball. There will be turbulent flow on the sim side, and again there will be turbulent flow on the non-sim side. This is strong turbulent flow on the rough surface or rough side of the ball, and this is the weak turbulent flow on the sim side or on the shiny side of the cricket ball. This is the turbulent flow on the sim side of the cricket ball. The turbulence occurs before reaching the sim location. Yeah, this is the sim, and turbulence occurs earlier, more earlier, before reaching the sim position. In this case, the laminar flow. In this case, the laminar flow on the sim side is converted into. In this case, the laminar flow on the sim side is converted into turbulent state relatively early before reaching the sim location. The sim actually has a detrimental effect. The sim actually has a detrimental effect on the turbulent flow or on the turbulent boundary layer touching the sim side of the cricket ball by making the layer thicker and weaker, by making the turbulent boundary layer thicker and weaker, and separates earlier it therefore separates earlier than the turbulent layer over the non-sim side of cricket ball. Turbulent layer over the non-sim rough side. So this is what weak turbulence state, and on the right hand side turbulent flow is strong. A is the point of separation from which weak boundary layer is separated from the sim side of cricket ball, and B is the point of separation. Again, we can explain this case here. This is the sim of cricket ball. This is the sim of cricket ball has detrimental effect. That means the sim uh, convert the turbulent flow more thicker and weaker. This turbulent flow on the sim side becomes weak due to the detrimental effect of the sim, and the turbulent flow on the non-sim side or on the rough side is comparatively strong. A is a point of separation from which weak boundary layer will be separated from the sim side of the cricket ball. On the right hand side, we can denote more turbulence. This is the strong turbulent boundary layer, and here more turbulence occurs on non-sim side and less turbulence occurs on the sim side of the cricket ball. Less turbulence occurs on the sim side of the cricket ball. On the non-sim side, for a strong turbulent boundary layer, air will be flowing with greater speed v2 in opposite direction, and on the sim side for weak turbulent layer, air will be flowing with lesser speed or smaller speed v1. For the sim side, greater pressure P1 acts, and for the non-sim side, where strong turbulent flow occurs, lower pressure will be acting. as there is more turbulence on the non-sim side, as there is more turbulence on the non-sim side with higher airspeed, according to Bernoulli's theorem. According to Bernoulli's theorem, that is sum of pressure energy, kinetic energy and potential energy per unit volume remains constant. A lower pressure P1, a lower pressure P2 acts on the non-sim side towards left, and a higher pressure P1 will act on the sim side towards right, on the sim side of the ball, that is towards right. As a result of pressure difference P1 minus P2 and also of lateral force F equal P1 minus P2 into A will act towards right. That means from sim side to non-sim side. Due to pressure difference P1 minus P2, a force F equal P1 minus P2 into A, where A is the area of cross section of the cricket ball. A force acts on the ball laterally from sim side to non-sim side. A force acts on the ball laterally from the sim side to non-sim side of the ball, and the ball will swing, and the ball will swing towards leg side. The ball will swing towards leg side. That is, the ball swings in a direction. That is, the ball swings in a direction in the reverse direction of the sim position. In a direction in the reverse position of the sim position. The ball swings in a direction that is opposed to that of the ball swings in a direction that is opposed to that of the sim. Now we can draw the wicket at the batsman end and offside and leg side of a right-handed batsman, and also we can draw the wickets at the bowler end. Wickets at the bowler end. And this is the cricket ball, and its seam will be angled towards offside at certain angle. This is the seam which is angled. This is the seam which is angled at certain angle of 20 degree towards offside. Seam is angled towards offside, and ball will swing towards leg side in mid-air before striking the ground. That is what a reverse swing. Seam is pointing towards offside, but the ball swings in the reverse direction. That means the ball swings towards leg side. The ball swings towards leg side. That is reverse swing occurs. Reverse swing occurs. Hence the ball swings. Hence the ball swings towards leg side in mid-air before striking the ground or the pitch. The ball swings towards leg side in mid-air before striking the ground through though the seam of the ball is angled towards offside. Now we can view a video. In this case, air is flowing in the opposite direction of motion of the ball. The seam is pointing towards offside, and there will be turbulent flow on the both sides of the cricket ball. This is the turbulent flow. There will be weak turbulent flow on the sim side and strong turbulent flow on the non-sim side, and lower air pressure acts on non-sim side, and higher pressure will act on the sim side. And here the ball will swing towards leg side. Now you can denote the direction along which the ball will be thrown. So this is the direction of flight of the ball, direction of ball's flight. And air is flowing in the opposite direction of initial motion of the body. Air flows in the opposite direction, And this turbulent flow occurs on the seam side, and airflow is tripped. Airflow is tripped by the seam of the cricket ball. Airflow is tripped by the seam in turbulent state. Airflow is tripped by the seam in turbulent state, and this turbulent state will be weak, and the seam has the detrimental effect, and the seam makes the turbulent flow more weak and thick. And for this weak and thick turbulent boundary layer, a greater pressure will be acting on the seam side of the cricket ball. On the other side, means on the non-seam side, turbulent flow touching the seam side of the cricket ball. This is the turbulent flow. There will be turbulent flow on the both sides of the cricket ball, but strong turbulent flow. There will be strong turbulent flow on the non-seam side, and for this strong turbulent boundary layer, lower pressure will be acting on the non-seam side of the cricket ball, and as a result, a lateral force F, which is equal to P1 minus P2 into A, will act, and the ball will swing in the opposite direction of the seam position. The ball swings towards leg side or towards non-seam side. The ball swings in a direction in the opposite direction of the seam position, and this is what reverse swing. And also we have a look of slideshow. For reverse swing, the ball looks like outswinger or inswinger when the ball is released, but it's completely opposite. It reaches the batsman. Here the seam is angled towards offside, and it is thrown in this direction, but the ball will swing towards leg side. Though the seam is pointing towards offside, the ball will swing towards leg side. Now wind is flowing in the opposite direction of motion of the ball, and a normal outswing grip with the super rough side on the left and rough side on the right, and seam at 20 degrees to left. And here super rough side behaves like a shiny side, offer lesser resistance to wind than the rough side. Super rough side behaves like a shiny side and offers lesser resistance to wind than a rough side. Ball moves laterally towards right. The outswinger finally reverses to an inswinger. To realize reverse swing, we shall have a video in which Simon Jones bowls reverse inswinger and Michael Clarke treats it as outswinger and withdraws his bat. In this case, Simon Jones does a reverse swing. He throws the ball with the seam position towards offside, but it swings towards leg side. And here, this is the seam position. Seam is angled towards offside. Seam is angled towards offside. In this case, seam of the ball is angled. Seam is angled towards offside or towards the fast slip fielder of right-handed batsman or Michael Clarke. Michael Clarke was the batsman, and this is the offside of the batsman, and on the right-hand side there will be leg side. The ball was thrown such that the seam was angled towards offside, and the non-seam side is rough side. Non-seam side is rough side. The ball swings towards the batsman. That means reverse swing occurs. That means in swing, conventional in swing occurs though the seam was pointing towards offside. The ball swings towards the batsman or the ball swings towards the leg side of the right-handed batsman. The ball swings towards leg side of the batsman. This is what reverse swing.